All right. All right.
Yeah.
Hi. Yep. Hi, everyone. So my name is Nicolas. I'm the TLM on the design tools and on constraint layout.
And my name is John. I'm TL for MotionLayout.
And so today we are going to talk to you a little bit about what we are planning and what's the current state of constraint layout and the kind of the next steps. The other things I just want to mention is that there is a Slack channel that we are welcome to go to, and will answers any questions that we may not have time to address in that talk, because there is a lot of content. All right, so let me talk a little bit about constraint layout. So I suspect most of you know quite a lot already about it, but just to remind people, essentially this was a window, this was a layout manager along with the tools. So we always created that tool in coordination with the design tools in Android Studio, and each one kind of fed the other. So ConstraintLayout 1 was bringing a lot of interesting functionalities for positioning your widgets, position relatives, dimensions, ratio. We also had this idea about helpers, and the helpers is an interesting concept. It's essentially, can we have elements in your layout file that are not views specifically, that you may not actually use to display something by themselves, but they are there only to help you set up your layout in a more straightforward way. So like guidelines and barrier and etc. And the other concept that's very important, specifically with MotionLayout, as you'll see with John, is constraint set. So the idea that we can get all the rules that drive a layout and encapsulate those into a constraint set. And what's nice is that you can then manipulate multiple constraint sets, switch them back and forth, etc. So just a quick overview of the design tools. If you never played that, we constantly iterate on them, by the way. So even like in Android Studio 4.1, we added a bunch of new things like a 3D transform panel, etc., etc. So there is a lot of stuff in those tools, and they can be very, very convenient to accelerate your design. Just briefly, I just wanted to chat a little bit about that. Sometimes I get engineers that come to me and ask me about constraint layout, and it's like, oh, are we supposed to use it all the time? Not automatically. We always have other layouts in Android in your toolkit, and essentially, if you have very, very simple situation that frame layout works for, just use frame layout. That's going to be faster than constraint layout because it does a lot less. So, but if you don't need the functionalities of constraint layout, that's fine. Same thing for linear layout. In some situation, it's simpler to use linear layout. I would say that in the rest, yes, sure, use constraint layout. All right, so a quick recap on constraint layout 2. So on constraint layout 2, we added quite a few things, both in terms of the layout, helpers. We added programming APIs as well, so you could do more stuff programmatically. And of course, we added MotionLayout, sorry, and the companion Motion Editor in Android Studio. So let me cover a little bit more the virtual layers. So, and I'll use Flow, one virtual layout that brings interesting stuff to constraint layout. The idea of virtual layout is essentially those are other layout managers, but they can be encapsulated into a constraint set. They don't add anything in the hierarchy. So it's an extension of the helper concept. And what's nice with those helpers is that they simply reference your widgets. So that means you can have multiple helpers referencing the same widget. So you can think about it as a helper implements a behavior, and you can tag multiple behaviors to those to your widget. So that can be very convenient. So let me talk about Flow specifically. You see how you can use it. It's relatively straightforward. You just reference the IDs of the views that are contained, if you want, into that flow. Flow itself is a view. So you can actually constrain Flow like you would with any other widgets. You can set a background, whatever you want to do, that's the normal view. But what it will do is apply a set of rules to the element it refers to. And specifically, we essentially get all the behaviors of a linear layout with an added twist where you can also wrap elements if you don't have enough space to contain all your elements. So it's a little bit like a flexbox layout. Internally, what we do right now is we just use the chain. So if you are familiar with chains, essentially Flow lets you create chains in a more straightforward way. So just to give you an idea, you can set up you can use similarly, you can specify which type of chains you want in Flow. So you have the typical, the spread inside, or a packed chain. And what's interesting, as I mentioned earlier, is that you can go beyond that. You can, wrap your elements if you don't have enough space. So if you have this and enough space, that's fine. It's just a normal chain. If you don't have enough space, then no, your elements are going to be outside of the screen, and that's not automatically what you want. So with wrap chain, you'll basically, have your flexible layout like that. You have the default spread chain behavior. You could also specify, a pack chain. You can in fact specify different behaviors depending on which chain, on the start and chain, etc. And another nice thing is you could even specify how many elements maximum you want per dimension. So if you look at that, it looked very similar to a table, but it's not. Like if that element in the middle was a bit bigger than the others, then they are not aligned anymore, right? They were only aligned in my previous example because they were all the same size. So we have another mode called wrap align that essentially does that takes your elements and align them like if they were a table. So that can be very handy to just create a quick table-like UI within a constraint layout. Let me quickly show you like the tools in Studio to do that. So first thing is that we have those tools attribute that lets you specify positions. So that way, even if those elements have no constraints, you can manipulate them nicely in the editor. So in 4.1, we added this little toggle that show you what actually happens if you push it on the device. And that's kind of convenient if you want to test things. So here I went ahead, selected the elements, created a flow out of them automatically. And then here I'm just constraining that flow, horizontally and vertically in that parent. The other thing that's nice is we added a new panel. So you can specify the orientation. And notice here that this is not exactly the order I wanted. So you can go to the reference view and just manipulate them like that. You can also manipulate them from the component tree, but that's another way that you can do that. And again, go back and you can modify some of the attributes. Notice here that they do indeed go outside of the screen because the default mode is not wrap. So you can add a chain wrap and then they will wrap as in my previous example. Similarly, you can do the aligned, or I can set the maximum number of elements and you'll see them there. So that's kind of a very convenient way of organizing your layout and see the results straight from Studio. All right, and now John is going to talk about MotionLayout.
So MotionLayout, you can do a lot of things with MotionLayout. Here are a bunch of videos of different screens that use MotionLayout. Some of them most of these are just examples that we've built or people within Google have built. But let's talk a little bit about what MotionLayout is. MotionLayout is a view group. Its subclass is ConstraintLayout, and because it's subclass is ConstraintLayout, you get all of the features of ConstraintLayout, helpers, relative constraints, all that stuff. But what does it do? Well, it allows you to position the views just like you would in ConstraintLayout. But in fact, you end up with two states or multiple states, and then you can animate between those states. And the states are really represented by constraint sets. It also allows you to do touch handling, whether it's just clicks or swipes. So how does this work? With MotionLayout, you're going to transition between two states. So you'll have a start state and you'll have an end state, and you'll have a transition between them. And when you do that, you can add a keyframe or keyframes to be able to change or deform the transition between those two states. without any keyframes, it will kind of do a mostly linear transition between them. And in fact, you can have many states and many complex arrangements of states. And how does it all kind of work on the inside? Well, you have your normal layout file. So anybody who's built layouts in Android has these files. And in fact, you have a XML file called a motion scene, which is pointing to the layout file, which is the layout file is pointing to the motion scene file. And in the motion scene file, you have constraint sets and okay, and what's happening? Oh, okay. And you have base states and constraint set provided states. All the constraint sets actually contain the entire state. It's captured through sort of an inheritance hierarchy in them. The constraint sets have essentially all the tags you would have normally seen in a layout, but they're now just labeled constraint and the ID. And that's saying, go find this object in the layout and apply these constraints to it. Now, what is a transition? A transition says which states you're starting and ending in, whether you want to support on clicks or on swipes. It provides you with the ability to then add the keyframes to manipulate it. And keyframes can be many things. It can affect the position of various attributes. It can also trigger commands on hitting parts. And there's a powerful set of things called key cycles and key time cycles that allow you to make oscillation effects. And we'll see. But key position is the one that actually affects the layout. So it's moving the layout attributes, your bounds of your views on the screen. And we have three different coordinate systems for it. We have a parent relative, which is essentially what you would normally think of as the coordinate system of a view. The parent's top left-hand corner is the right corner, is the 0, 0. The parent's bottom right-hand corner is 1, 1. But we actually have two other coordinate systems, and these are actually needed because when a view moves within a constraint set, you don't know the actual coordinates until it's realized on the phone, because the phone could be in landscape or portrait. It could be a bigger phone or a smaller phone. So you actually need to have coordinate systems that help you with what is the motion going to be. So the first one of those is called delta relative, and essentially 0, 0 is the starting location, and 1, 1 is the ending location, and it's the percent x is the x axis, and the percent y is the y axis. Path relative rotates that so that the x-axis is the line between the starting and the ending state, and the y-axis is perpendicular to that state. Now, the other thing that we have, and I'm going to just show a few videos of it, is key cycles, and they allow you to make these kind of complex, custom coordinated views. The other thing we have is key time cycles, and that allows us to do oscillations in time. Key cycles oscillate you with respect to the animation position, where along the swipe or the gesture, or whatever you're making. Key time cycles are in hertz. They operate with respect to time at all points. Now, let's go through a very quick introduction to how you would actually go about doing this. You have a normal constraint layout, and you can right click on it, and you can say convert it to motion layout. Create it, go into the motion editor, and it'll convert it to motion layout. And you'll see this where you have the views on the left, like you normally have. You have the layout, and you have an overview panel showing you your starting and ending states, and you have a view for transition. And when you have a transition view, when you select a start state, you can manipulate the start state. You can go to the end state and manipulate a view at the end state very simply. And now that you have both states set up in a way you like, you can actually go to click on the transition, and you can see the animation. Now you can stop the animation, position it at some place, select a key position, and let's add a delta relative, and you see it distorts the position. Now, once you've done that, you can actually also do something like add an on-click handler, and that's one of the on-clicks. And you say, oh, when I press this button, I want this animation to occur. And if you run it, that's what you'll get, actually. You'll get the exact motion. So you see, it's really easy to get started with motion layout, to do a quick demo, understand what it's all about. Now, Nicolas, let's talk about where we are now.
All right, so that should give you a good idea of the current functionalities. We actually just released 2.0.2. I would highly suggest that you upgrade to this version if you have not done so and you are on the 2.0 branch already. We addressed a couple of bugs, but most importantly, we re-enabled a lot of the optimization. So it's actually quite a lot faster than the previous two releases. And in some of my tests, it's quite a bit faster as well than 1.1. So I'll definitely check it out. The other thing that we are working on right now, it's really more about infrastructure, so it may not directly impact you so much, but it's impacting us quite a bit, and that's the move to GitHub, so that we want to essentially do the full development of constraint layout and motion layout on GitHub. And another thing that we are looking at for the next release for 2.1 is we'll drop the Android.support package name. I think that by that point, everyone should be on Android X anyway, but just a heads up. All right, and John can talk a little bit about the learning more.
So how would you learn more about all of this stuff? There's a lot here to unpack, and there's a lot of things you can do. So one of the first things you can do is actually go through one of the Codelabs. It's a really good Codelab. It'll take you through a basic setup and building some simple animations. The other thing that you'll find a lot of are some more advanced samples. And actually, Sean talked about this today, these samples and his experience building them. So these samples are something you might want to take a look at. The other thing that we're building is a series of YouTube videos called motion tags. And each video is very short. It's about 3 minutes long. We shoot for around 3 minutes long. And each video covers one particular tag or two tags that are related to each other, so that you can actually say, oh, how does a key cycle work? And you can go to the video on key cycles. And you can see it has lots of animations. It shows you things with respect to the toolkit. It's very fun, interactive, it's quick. The other thing it's good about those is you can actually post a question underneath it and we'll talk. And all these animations you're seeing here, including this one, are done with motion layout. Okay.
All right, so let's talk a little bit about 2.1. That's the next release. And there's a couple of things. As I mentioned, there's a bit of infrastructure work on GitHub. But we really want that release to be a short release cycle. 2.0 kind of stretched a little bit the definition of a release. It took a long time, and we don't want to repeat that. So we are really aiming at getting 2.0 finalized by the end of this year. So that's going to be a relatively short cycle. Part of it is, as it's kind of us moving the full development process to GitHub as well, right? So that's what we want to get. That said, it's not going to be just like a release with no features whatsoever. We do want to do a few things that we had kind of pushed away from 2.0 that were kind of ready, and we want to include those. It's really with a focus on improving the ease of use of the library and trying, now that we have quite a lot of people using it as well, so we got interesting feedback, and we do know some areas that would benefit from this kind of stuff. Basically, sorry, for some reason I don't have. I think I love TaxX actually. Can you do the next slide? All right. So basically, that's what I was mentioning is this is the current situation, right? We have ConstraintLayout, the Android library. ConstraintLayout is actually two libraries. There is the Android library that operates on the Android views, and there is a solver library that includes the linear equation solver and also the optimizer and stuff like that. So MotionLayout is on the Android side. And what we want to do is basically to, next slide. Yeah, it's very frustrating. Sorry, I was able to control John's computer earlier, but it seemed to have broken down. So one thing that we want to rename that solver library into core, because we are going to, next slide, we are going to essentially move the motion engine fully onto that core library. That will help being able to have motion layout in other situations like compose. All right, next. All right, next. A couple of additional stuff with the layout. So we, as I mentioned, there is a few things that we know we could easily introduce that I've been a few things that people have asked for a while. So adding the ability to constrain the baseline to not just another baseline, but also to top and bottom, setting a margin on that baseline. Supporting negative margins. Right now we kind of enforce that any margin on a constraint has to be positive, but in some situations it would be kind of nice to have a negative margin. So we'll support those kind of things. For helpers object, often they don't really have a dimension by themselves. So in fact, enforcing specifying layout width and layout height is not really necessary. So we'll probably get rid of them in that release as well. Next. The other thing that we want to focus on is the scalability, essentially, of the whole system. We are seeing motion scenes getting quite large at this point. And so we think we can help with having separate constraint files, possibly dealing with includes. The other thing that is kind of handy is constraint overlay. So one thing that you can do right now, so essentially when you create a constraint set, that has to contain all the specification for the element you're constraining. And we did that so that it's very, very straightforward and there is no surprise about what you get. The flip side of this approach, of course, is it's a little verbose, right? So we did something in ConstraintLayout 2 for MotionLayout where we kind of split up the different attributes you can use into the different types of attributes, like the transforms or the constraints or other attributes like the properties. But the granularity is still relatively high. So if all you want to change is a margin on a constraint, for instance, you still have to redeclare all the constraints. So as I said, you get the advantage is that you get something that's very straightforward. What you wrote is what you get. But yes, you do have to recopy. So constraint overlay will allow you to only replace the one attribute that you're interested in to modifying. It's a little less straightforward because there are situations where that might lead to a result that you did not plan. So hear me out. Like if you set up a constraint of just on the left, your button is going to be, or your widget is going to be aligned to the left. Great. Now in your overlay, you set a constraint on the right. You may think that your button will move to the right, but in fact, it will move to center because we have this concept that to do centering in constraint layout, you have to do both left and right, or start and end. So this is the kind of stuff we wanted to avoid, at least in the first release of motion layout. But definitely, having this overlay concept would definitely help getting stuff a little smaller in your file. And same thing as what we have for derived constraint set. We want to do derived transitions. Next. Another thing that we've been experiencing with motion layout is some difficulties about animating text. So we're actually thinking about introducing a helper object to do simple text. So it's not going to be you animate entire paragraph of text, but most of the time, or at least most of the situation we've seen, is people want to animate just a title or a subtitle, stuff like that. And we think we can provide like a small view that would only do that just specifically, but do it right and fully integrated with the rest of motion layout. Next. Another helper that we think we should be able to learn into one is the carousel. So what is a carousel? So you can look at it like that. It seems like it's a recycler view, right? But the big difference is it's actually all in motion layout. So you can actually apply various transforms, and that can be pretty powerful. So here's how it works. Next. You can start with essentially a few views that you can move around. Next. And if you do that, what actually happened under the hood, next, is we essentially move this view like that. And next, we can actually simulate that by using different constraint sets. And this basic mechanism I just showed is in fact what recycler view does. Yeah, so we're not exactly reinventing the wheel here, but the big advantage is that by doing it by views you specify, you have access to all the possibilities of motion layout in terms of transformation. So and you can, well, can you go back 1 sec? And so you can basically just do really interesting transform and etc. So again, it's not really to replace recycler view. Like if you have a really long list of items that are laid out in a specific way, just use recycler view. It's meant for that. It's really optimized. But if you have something that is more like a carousel, it's like, and where you want to do interesting transforms, doing this type of animation with recycler view is kind of not great. And so we think that with a specific helper like that will make things a lot easier. And that helper essentially will let you specify the different state that you use for the forward and backward transitions, the center object, etc., and we'll do a lot of the bookkeeping for you. Next. So this is how it looks like in Android Studio, in fact. So you have here, I have a couple of states. I have to play the animation. Yeah. So you can specify like the start and end state, and you can see that if I select the forward transition, you'll see how I can, in fact, do that carousel effect. But the nice thing is that I can easily modify everything, right? And same thing for the backward transition. So if I go on one of the constraint set, and if you play it, you can even get the effect that we're going for straight in Studio. It's just that at runtime, that carousel object will automatically, with like a little adapter essentially that you provide, you'll basically populate the element as you need, kind of like recycler view again. But what's nice is that all the tooling is there. So if here I want to do a rotation or something, everything works. So we think that's going to be a pretty convenient little helper. Next. Rotation. John?
Okay, can you guys hear me?
Yeah.
Okay. So one of the new big features in the system is in 2.1 is rotation support. We're essentially trying to provide a collection of APIs around how to make things rotate in smooth and interesting ways and move around in sort of pleasant ways. Now, this is just a quick demo that Nicolas did. But let's dig into a little bit of what we had before. Constraint layout has relative positioning. And as you can see, you can say, I'll constrain this, the Earth to the sun and the moon to the Earth, and you can give them angles, and it actually works out pretty well. But we didn't really do anything with that in motion layout before. And in fact, if you try to animate those kinds of relationships, it will want to move in straight lines, which is exactly the opposite of what you want. Well, now with polar mode support, you can say with just adding animate relative to, you can say that you want those motions to be essentially in a polar coordinate system. And as you can see in that animation, it moves smoothly. But what's interesting is your layout constraint angles are actually understood. And so even though in theory, nothing really changed about the starting and ending position, you can see from the rotation of 360 in the circle angle, I need to move in 360 around that, around it. And they can be combined and produce a fairly complex motions with multiple amounts of rotation, and it'll all come together. Now, you can also even support key positions in polar mode. So in this particular case, you see the motion is retarded because percent y is the angle. And so you're saying in this key position, you're saying for the first half of the rotation, do not move the rotation more than 1.2 of the rotation, 20% of the rotation. Now if you look at this animation here, it's a very complex animation being set up here. We have the Earth, the sun, and there's a little rocket moving around, and it moves to meet the moon. And notice that we say motion path rotate, and you see the rocket is actually moving is oriented towards its motion. That's because the entire system is aware of all the motion that's going on. And you can sort of see it more detailed here. Also notice we added a key position, and the key position is that little diamond right there. And what that key position says is, by saying %x, it says do not move the radius of the rocket for the first quarter of the rotation and have it complete half of its 2 rotations. And so the first circle, it loops the Earth, and then after that, it takes off and moves towards the moon. So the other things we have is we have the OnSwipe, which we were using before for drag rights and stuff, now has a polar mode, essentially, where you can say rotation center ID, and it will rotate about, it will accept inputs about that rotation. And in fact, you can also give it a center location. You can also give it an object that is being laid out in polar mode, and it will track that object like you're used to with all of the previous anchor ID support. So if your anchor ID is in polar mode, then it will actually work the way you would expect it. In this particular case, we are also doing another new feature, which is transform pivot target. So if you want to do rotations, which is the rotation had support for a thing called pivot, and there's pivot X and pivot Y, which is the pivot location, but it was always difficult to calculate where to pivot. Now you can actually say your pivot point is actually the center of this other view. So in this case, I'm pivoting the angle around the Earth. And you can actually produce fairly complex pivots that way because and the pivots can be moving. So you can have all the power of rotation X, Y, and Z, but now it's rotating about this pivot point. The next thing we did, which is quantized the motion. So what this allows you to do is say, I want to go through a normal, in this case, I'm doing rotation, but it will apply to anything. But I want it to quantize in 12 steps. So it will move in 12 increments. And each of those increments, you can actually use an interpolator. In this case, I'm using the bounce interpolator, and you see that one of them is actually, the yellow one is bouncing when it rotates. So putting that all together, and I did a little bit of a fancy one. This is something I built last night that is showing kind of a more sophisticated, fancy drawing, but it's essentially using pivot points and rotations and rotating about specific views. So it's actually, there are a lot of power here with a lot of kinds of interactions that have anything to do with rotation. One of the other features we've added is image matrix transform. Now normally an image view has transforms built in, but basically you can set and get the matrix. What we've done here in the image filter view and the image filter button is add support for more or less intelligently providing transformation capability. So you can set a zoom factor where 1 is the size of the screen, 2 is like you wanted to zoom in by 2. You can set pan to 0, which is the center of the screen. Pan -1 is all the way to the left, +1 is all the way to the right. So it's really easy to make kind of clever pans and zooms, and also rotation. And that's separate from the view itself. So that's inside the view, the image is being displayed that way. Also remember, image filter view has the ability to clip to rotation. So you can just set the rotation %, in this case, the rounding % to 1, and it will essentially clip the entire view as a circle. So you can produce kind of clever, interesting effects that way. Now,
all right,
Nicolas?
So quickly, because we don't have too much time left, but let me cover a little bit of what we are doing with Compose. So Compose is the kind of next-gen UI framework on Android, and we actually ported a constraint layout in Compose. So I'm going to cover that a little. And as I mentioned, we are also working on porting motion layout as well. The way we are thinking about this whole stuff is essentially constraint layout and motion layout brings you a lot of new concepts, so like a toolbox for you to do layout or animation, and we kind of want to bring the concepts and the tooling to Compose as well. So it's actually the same library. So what you have in Compose is using that solver library I mentioned earlier. It's just that you set up those constraints with a Kotlin DSL. It's also a work in progress, so we're more than happy to hear feedback and features that you may miss, etc. But right now it's actually pretty. It covers like most of the API, or if not everything, and it tracks as well the updates on the solver library. Next. So essentially, the other thing that you have as well is that in Studio, if you're using the canaries of Studio, you have the layout preview. And beyond the layout preview, and there is a lot of interesting stuff we did there with sample data and showing you all the composable. You also have this really nice mode that's called interactive preview. And I'll demonstrate it later. But essentially, you can have your code on the left and the preview on the right. Next. So how does it work? First, you go and you create your composable. Next. And that's very straightforward. ConstraintLayout is a composable. You include it like that. You notice this @preview annotation. There's, again, a lot of different attributes you can pass to that annotation to control the type of preview. Next. And then you add the composable that are part of your screen. So the image, button, text, etc. Like normal compose stuff. Next. So then you have to add references, right? So we have those composable. Next. and you need to reference them, because constraint layout, the whole idea is that you can position stuff relative to one another, which means that we need to know about those elements. And, and because that can be done in any order, you kind of have to have a notion of, hey, I have IDs, kind of. So we call that reference in Compose. So you can just create them like that, and you can specify the constraint inline as a modifier. So just by having modifier.constraint as the reference, and then you have in brackets, you can do the constraints. Next. And that's it, add constraints. So that's one way of specifying a screen in constraint layout, and you have a little DSL to specify the constraints, like in blue on that slide. Next. There is another mode which actually uses constraint set. So instead of creating the constraints in line with the rest of your code, you can separate them into a constraint set. So this is the same stuff, but done in a constraint set. And why would you want to do that? Well, for the same reason that we do that on the the normal Android version, is that you can swap those constraints together. So next. So there is another constraint set that's going to change the screen a little bit. And next. So, and you might have to play. So if you see now, I just hooked up the button, and when I click the button, the constraint sets are being swapped. And so you get a different layout. Next. So to recap. So for constraint layout, essentially, next. We want to keep that like a relatively simple model, but a model that also allows a large expression space, right? It's very powerful. We also want to have a really strong design tool integration, and we will continue on that as well. We continue to iterate on those. It's okay to use linear layout if you want to use linear layout, that's fine. Like the idea for constraint layout is to help you, right? So when it makes sense and when you find those the capabilities interesting, do use it. But in a very simple case, that's okay to use a linear layout. Next. For group behavior, flow is very powerful and very interesting, specifically if you want to have the kind of UI that automatically adapts that with like the wrap content, that can be pretty handy. Next. And for motion layout, John?
So the big takeaways about it is it's easy. It's making creation of animations very easy. So it's amazing how quickly you can actually build an animation with the system. It also is great for when you have to modify the animation. So for instance, you might want to have a slightly different version for a landscape versus portrait, or a high-powered phone versus a low-powered device, things like that. It's very easy to make sort of little variants of them. And a kind of a big part of that is the fact that it separates the animation from your logic. So your views are there, you have people who are populating your views, they're doing that stuff. You write your animation, and then it's sort of added on top of the layout that way. And that kind of makes the whole thing sustainable. So where you can, if you have, say, a small change to the UI, you want to add a new button for something, you don't break the entire world because the animation is somewhat separate. You can easily sort of add one more button to your system, add one more button to the animation, and manage a whole collection of them.
All right, so just a slide with some documentation. So, please, you can look at those. There's a lot, there's a Codelabs and etc. So check that. The GitHub sample is particularly useful as well. Next. So that's the end of the talk. Keep in mind for now, even though we are moving to GitHub, we are still using the issue tracker, at least for the time being. We might move to the GitHub tracker later, but for now, if you have feedback or bug, please file them there. And I think that's all that concludes this talk. We'll hang out into the Slack channel if you have more questions, because we are way over the time allocated for this talk. But thank you very much, and thanks to the organizer. Virtual conferences, it's not easy, so thanks a lot to them.
Yeah, all right, thank you. So I'm not gonna, I guess we don't have really much time for questions, but on the Slack channel, I'll ping them again in the chat here. The channel is in the chat, so is the link to the Slack channel place as well.
Yes, we're jumping to the Slack.
Yeah, yeah. All right.
All right.
All right. Thanks, everyone.
Thanks.